In the blue certification, we're going to be creating a tap guide, which is used to line up your holes and keep your tap straight when tapping. You're going to want to obtain your materials from the shop supervisor on duty. They'll give you two things, a piece of square stock and a piece of round stock. Right now we're going to focus on the square stock, which will be turned into the block component of the blue certification. Similar to when you laid out your part in the green certification, you want to think about your cuts before you actually do it. So laying out is very important. However, before we lay out our part, we want to make sure that everything's square. I have here with me a square, and we're going to use it to see how square our part actually is. To use this, you just take your square and put it up against your piece and hold it flush against it. You won't be able to see this in the video, but when you're looking at it, you want to hold it up to the light and see if you can see any light in the cracks between the square and your piece. For more help with this, you can ask the shop supervisor on duty to assist you. I know that this piece is not square, so the first thing I'm going to do is go over to the mill and face off one of the sides. Before we actually begin cutting our material, we want to think about planning ahead and looking at the cutting tools that we're going to use. Tool selection is very important in the machining process. There are many different types of machining tools, but right now we're going to focus on end mills. There are many different types of end mills. They can be made from high-speed steel or even carbide. Different types of tools offer different types of benefits. Right here we have a 2-fluted end mill. You can also have 4-fluted end mills or even 3-fluted. This tool is also a double-ended end mill. You can have single-ended end mills. And the flutes, which are your usable cutting surface, can change in length or even in diameter. For the purpose of facing off this surface, I've chosen this single-fluted end mill. It'll give me enough room to cut the entire piece in one pass. Surface finish is a very important part of your end product. You can get many different types of surface finishes. For example, when a part comes in as a raw stock, you're going to have a surface finish such as this, which is smooth and usually produced by the process in which it was created. When we get our rough dimensions, we usually use saws. Saws will produce a saw cut, which is usually rough to touch and characterized by parallel lines. Depending on the type of cut you use, you're going to get different surface finishes on your part. You can either use the side of your end mill or the bottom of it. Using the bottom of an end mill will produce a circular pattern. It will take several passes with the tool to get this type of finish. However, if you use the side of the piece, you can often do this in one pass. It'll produce a much smoother finish. For the blue certification, you're going to have to demonstrate two kinds of surface finishes using both the side of the end mill and the bottom. I'm here in the blue room next to our large Grizzly milling machine. We're going to begin cutting our material so that we can face it off and get it nice and square. However, before we do that, we have to set up both the machine and our workpiece in the vise. I'm going to start with setting up our cutting tool in the machine. There's several ways to fasten a tool inside of a milling machine. Most commonly, however, we're going to use a collet. You can see a collet is constructed of a metal shaft, and it's got slots all up the side. This is going to eventually get pulled up inside the spindle, and it's going to hold tight onto our part. I've already selected the correct collet. However, there are different sizes, ranging from very large to very small. And you want to get the right one for your tool. It should fit snugly, enough so you can move it up and down, but enough to hold it. Now, when you place your tool inside the collet, you want to make sure that you go pretty much right up to the end of the flutes. This will ensure that you have enough surface area that you're holding the tool properly, but you're not going to damage the flutes. So you see this line right here, this is called the key slot. When putting your collet into the spindle, you want to put your finger up inside the spindle and feel for a little nub. That's going to line up just with this key slot. We're going to stick it up in there, and then we're going to hand tighten it. This will pull the collet up inside the spindle, tightening on the tool. Once you've tightened it by hand, we can either use this handle from the vise or the wrench found with the collets to tighten down this tool. You don't want it too tight, just enough so it can properly hold the tool. Once you fasten your piece, we can begin fastening our workpiece into the vise. You want to make sure that your vise is clean and free of any chips. And we also want to make sure that your piece is held parallel and nice and straight inside the vise. In order to do this, we're going to use parallels, which can be found inside the shop layout cabinet. You want to select the proper parallels, and you're going to place them in your vise. You're then going to take your piece and place them on top of the parallels. The parallels ensure that your part won't be skewed when you clamp it in the vise. Now you can see that the part is positioned nicely on top of these parallels. They make sure that it's nice and level. We're going to clamp the part now. I'd like to give it a little bit of downward pressure, just enough so that it's flush up against the parallels. We're going to tighten it and just give it a nice hand tighten, not too tight. You don't want to have trouble getting it off. But now our part's ready to be machined. Before we begin machining, I want to go over a couple safety issues. All of our machines are locked out in the shop. Before you can begin cutting, you want to make sure to ask the supervisor to unlock the machine for you. Once it's unlocked, you can use the on and off switch here, forward for clockwise and reverse for counterclockwise. For our purposes, we'll be cutting in forward or clockwise direction today. If you have any problems with the machine, you can use this brake on top to shut it off. So the machine's going, turn it off, and use the brake to stop it. We also want to make sure that we're wearing safety glasses, closed-toed shoes, and that we don't have any loose or hanging objects on our bodies, especially with such a powerful tool. Now I also want to address the directions in which you can cut. This milling machine has 3 different axes. Your x-axis, which runs parallel to the table and can be controlled by the 2 handles on the end of the table. The y direction, which will bring your part in and out and can be controlled with the handle on the front of the machine. And the z direction, which can be controlled with this handle. It will bring your table up and down. It's important to note that a milling machine has a tool that spins and a part that is fastened to the table which moves. This is different from the lathe, which we'll talk a little bit about later. Now, if we come and look, you can see that my part is nice, and we're going to try to line this up. And we're also going to have to look at it from this direction. You want to make sure that your part is positioned properly in relation to your cutting tool. We're going to try to do this in one pass, so we want to make sure that our cutting tool at least comes to the bottom of our part. I measured this part before we began, and I know that it's 1.5 inches. Our overall dimension is 1.25. So we want to make sure that when we're facing off this rough cut, that we don't take off too much material. So I'm only going to take off about maybe 50 to 100 thousandths. When machining with an end mill, there's 2 different types of cuts you can perform, either climbing or conventional. You can learn a little bit more about them in the handbook, but today I'm going to be using a climbing technique. It's also important to note that you want to keep a nice, smooth, and consistent feed so that you get a nice finish on your part.